the resource and between the resource and subject sets the policy which defines under what conditions that access is allowed. So this triad, subject, resource, and policy, is the foundation of the rest of the zero trust workflow, which we are going to see here now in this slide. So basically, now we will discuss how everything fits together. So every decision or every access decision, particularly in zero trust, involves three key components. First one is the PAP. So it's the policy administration point, or PAP, where rules are defined. The policy decision point, or PDP, which particularly evaluates all the rules. And the third one is PEP, policy enforcement point, which actually enforces the decision made by the PDP. So the workflow goes like this. So PAP defines the policy, PDP evaluates the requests based on those policies, and PEP enforces the decision in real time. It will be more clear through this diagram. So particularly subject, a person or a machine, if that machine or an identity wants to access a resource, uh, like a system or an application or a database, it goes through the policy, and within the policy you have many things, like PAP, where you can actually define the rules, PDP, which evaluates all those rules, and PEP, which actually enforces the decision made by the PDP. So this is the high level flow from subject to resource, and in between lies the policy. Now let's talk about PDP, or policy decision point. So policy decision point is the brain of zero trust. When a user requests access to a resource, the PDP checks all the context information, all the relevant policies. Who is the user? Is the device healthy? Is the EDR running? Is the user machine have the disk encryption enabled? So all those things are checked. Where are they connecting from? So location is also an important element. What is the resource sensitivity? So everything, all these things are taken care by the PDP, and it checks the the context based on all these elements, and based on this data, PDP decides whether to allow, deny, or challenge the request from the source. Some of the examples of PDP include, if you talk about the SASE SSE platforms, so Zscaler Central Authority is the brain of Zscaler platform, where all the decision making happens. Microsoft Conditional Access Engine, Prisma Access Policy Engine from Palo Alto. So these are some of the PDPs uh, when we talk about vendors, let's say. Now let's move on to PEP, policy enforcement point. Uh, so the final component is the policy enforcement point, PEP, which is like a security guard at the floor. It sits in the data path and actually enforces the PDP's decision. So if the PDP says allow, the PEP lets the traffic through. If deny, it blocks it. So PEP should be located, we will discuss in the next slide. So PEP should be located as close to the resource to minimize the risk and to minimize the latency. We will discuss this particular point in the next slide. Some of the examples of PEP are Zscaler client connector, Zscaler application connector, uh, SASE SSE gateways, Global Product Gateway from Palo Alto, Netscope, private access. So these are some of the examples from different vendors. Now let's talk about the control plane layer and data plane layer when it comes to PDP, PEP, and the overall architecture of zero trust framework. So, particularly about the control plane layer. So, PDP is basically the control plane layer of the zero trust architecture framework. Why? Because it handles all the thinking, all the policy evaluation, all the risk scoring, all the contextual decision making that happens at the PDP end. Uh, it is not in the direct data path, and it can scale independently since it does not process every or any packet on the data path. It is completely independent, so it can scale independently of the data plane layer. About the data plane layer particularly, so policy enforcement point, uh, it handles all the doing part and not the thinking part. So actual enforcement of access in real time happens in the data plane layer, which means happens at the PEP. It intercepts the traffic, it intercepts all the sessions, and it applies the PDP's decision. So it is directly in path of the user's request. So it is very important to consider the latency and reliability aspect. So this is about the control plane layer and the data plane layer when it comes to the zero trust architecture framework. Uh, Now, where should the enforcement point for PEP be located? So where should PEP live? Uh, there are many different, so there is no single ideal location for PEP. The answer to this particular question depends on the type of resource we are trying to protect. So, for example, for SaaS applications, it should sit in the cloud proxy layer, like a CASB or a secure web gateway. For private applications, applications in the data center, it might be so PB might be an app connector sitting close to the data center application, or it can be an SDP gateway. For workloads, it could be a microsegmentation solution, something like Guardicore or Illumino, where you can have the PEP close to the container or to the virtual machine. The closer your enforcement point is to the resource, the smaller will be the attack surface and stronger will be your control. So PEP should always be very, very close to the resource. Uh, Now, this particular slide talks about uh, particularly the PDP. So, PDP is basically split into two main categories or two main parts, I would say. One is called the policy engine, the other one is called the policy administration. So, policy engine is basically the actual brain of the PDP. So it gathers all the information, all the contextual data from internal and external sources. Uh, Internal sources like identity or the network context or the logging or the user and behavioral analytics information from the SIM platforms, and also if there are some malicious IP addresses or malicious domains, and threat intelligence has some useful data particularly for that user access. All those uh, feeds will be given to the policy engine, and all these internal and external resources or sources will help the policy engine to make the decision using an internal trust algorithm. Once the decision is made, policy engine sends the instruction to the policy administrator to generate some session tokens, and those tokens will then be transferred from PDP to policy enforcement point. So these session tokens are basically the authentication tokens, and based on those authentication tokens, PEP makes the decision. So let's make it more clear with an example. Let's say you have an HR staff or HR department, and an administrator defines the rule for the HR department that HR department can access the payroll application from compliant devices using multi-factor authentication. So this is the use case. So for this use case, policy decision point or PDP in the control plane, it gets all the contextual data from the identity platform for the HR department. Uh, it also evaluates whether the HR people are connecting from a known or a trusted location, whether the multi-factor authentication is enabled or if it is needed, because sometimes HR department people, they access it from a different location or a new location which is not known to the PDP or to the policy engine, that then it enforces the multi-factor authentication. And PEP is the data plane layer. So if an application sits behind a particular firewall, let's say, that firewall gets the context information from the PDP, and firewall also gets the session authentication token from the PDP, and based on the PDP decision, it allows people from HR department, based on many contexts, based on many internal and external sources, whether to allow or whether to deny the access to the HR application. So that's one of the example. Also, in this particular slide, I'm showing you about the policy decision point. What are the different sources for the PDP? So, like I mentioned before, uh, PDP, you get the information from the identity platforms like user permissions, users are part of which particular group, conditional access, location based information. So identity is one of the most important element of PDP. Endpoint level telemetry, for example, endpoint machines having the EDR agent from different EDR vendors like Sentinel-1, CrowdStrike, that tells about the risk score of the endpoint or the laptop the user is using. So whether the disk encryption is enabled or the user is running a certain process on the laptop. So this level of telemetry is being fed to the PDP to make the decision. The threat intelligence from various feeds like VirusTotal, Mandiant from Google or IBM, that is also an important aspect. And then the SIM and the XDR platforms or log aggregators, where you have uh, all the logging information, all the user activity which is being monitored, all the trend analysis you can make. So, for example, if a user uh, is having a certain way of accessing the applications, a certain time of accessing the applications. So, based on the regular activity of the user, you will get a certain risk score. And if there is a deviation, for example, user suddenly logs in during midnight to access a critical application, same platforms, based on the behavioral analytics, they detect it as something suspicious, and they can increase the risk score for that user from, let's say, low to medium. So all these elements important uh, are important uh, contextual information sharing criterias for the PDP.